Okay, so next video 10 covering the test 2E portion from 85 to 94. Okay, so here 85. Baking soda decomposes into sodium carbonate, steam and carbon dioxide on strong heating. For example, when you are cooking, how does this happen? Let us see in the form of a chemical equation. The word decomposes here is important. So here, keep some space. We're going to write the chemical equation. Sodium, okay, bicarbonate. Baking soda real name is sodium bicarbonate. So this baking soda, write the formula above it, Na1 plus, and you know bicarbonate ion is HCO3 1 minus, so valency 1 1, so this is a solid if you want to write, okay. Now you do strong heating, like when you are cooking over high temperature, over the stove, strong heating, okay. So when you do strong heating, what do you get? You get this, keep in your mind, sodium carbonate, so you write here, sodium carbonate, and write the formula, Na1 plus, right, and carbonate ion, yes, CO3 2 minus, so the 2 will go at the back of Na. Then you get steam. Steam is nothing but the same formula as water, water in the gaseous form, so you can write G if you want. And then you get carbon dioxide, so you write here carbon dioxide in the gaseous form, so CO2, G if you want to put. Even if you don't put, we know it's a gas. So now this is what happens. So we need to balance this equation. So let us do this here. Balancing of chemical equation. So make the table again, and then serial number, left hand side, right hand side. Then first atom here, Na, 1 on the left side, as you can see back side. Here 2, so that cannot be. To balance it, to make this Na2, these 2 belong to Na, another one from, not to C. The one at the back subscript always belong to the atom in front, okay? We've been telling this. Now 2, so here also you need to balance, not from middle, you're not balanced, right in front, bigger than the subtext number. So now it's balanced. So take your rubber and now it's balanced. So the moment you do that, 2 Na, Na2. Then this H at the back is 1, right? So 1, 2s are 2H. So H is there, 2 on the left side. H here, 2. No H here, no H here, so that's why 2, 2. Then we've done this H, then C. C means carbon, okay? So C1, here also 1. No C, here 2, C, 1, 2. Here 1, but see, 1, 2s are 2. So left side also 2, right side also 2. 1 plus 1, 2. Then O is the only one left, so here 3. So you shouldn't forget there is a number right in front, means that number belongs to every atom after that. All the atoms here, sodium, hydrogen, carbon, oxygen now will possess this 2. So 2 3s are 6. O, so O is 6 on the left side, right side 3. Here 4 at the back 1. No, this 2 doesn't belong to O, okay? Belong to H. So 1, 3, 4, 5, 6. So all are balanced, you can see here. You keep on doing this table, and when you get comfortable, then you can stop doing this table. Okay, so this is 2 molecules of sodium bicarbonate on strong heating decomposes into sodium carbonate, steam and carbon dioxide. The word decomposes means one big single molecule, only one compound, right? Break into 3 smaller compounds. When one big compound breaks into 2 or 3 or more smaller compounds, that process is called decomposition reaction. So all decomposition reactions will have only one substance on the left side, and there will be at least 2 or more substances on the right side, because they have broken down into smaller ones on the right side. That process is called decomposition reaction. Okay, now this is balanced. Now let us go to the next question, 86. Just write along with me. 86. Now 86 is in another section. 87. Go to question number 87 on your tuition note. Those who have your tuition note, you not write. Those who don't have, you can write the chemical formula. The chemical formula of washing soda. We have discussed in this section 2E, sodium hydroxide. Then we have gone to baking soda, third important compound. We are studying the important industrial compounds. Okay. Then this one, washing soda. Sodium hydroxide, baking soda, washing soda. So this washing soda is the substance used in making detergents, okay, for washing purposes. mainly. So it is also used for other purposes like in glass industry, but main use is for washing purposes in laundry purpose. Is the chemical formula washing soda is, let us put a blank, okay? And you should note it's not blank, but you can make a blank on your note. And so, name, let us make it longer. The chemical formula of washing soda is, okay, this one. And, okay, so its chemical name, this is just to learn to write the name and the formula, okay, is what? Let's fill out the gaps. The chemical formula of washing soda, remember, is Na2CO3 dot 10H2O, okay? So write it down, 10H2O. So its chemical name, you can just look at this and write. We know by starter this is sodium ion, so sodium, this part is the carbonate ion, so we write carbonate, sodium carbonate. Then here 10 means we know the verb is called deca, so we write deca. And water means we call it as hydrate. So the real chemical name of washing soda is called sodium carbonate decahydrate. So this is just a matter of knowing it as a general knowledge. Okay, 87. So I'll go to 88, question number 88. I think we can just read that. How is washing soda prepared? Okay, write it down. How is washing soda prepared? Write down the question. Now this is how washing soda is prepared. It's prepared from a very common, readily available cheap substance called sodium carbonate. You can get the clue from the formula itself. You take this one, Na1 plus CO3 minus, and add proper amount of water calculated. Okay, properly amount is added. So each molecule will then take up 10 water molecules. Just get a clue. And so these two will join, and you will get Na2 CO3 dot 10H2O, which is washing soda. So you get here the washing soda. So this is a very easy process. When you add proper amount to sodium carbonate, some crystals will come out, and those crystals are filtered and dried, and then that is called the crystals. There are sodium carbonate decahydrate or washing soda crystals. So that's how they are manufactured. Easy process. Now 89. This one we can just read through it yourself. Write some uses of washing soda. So I think that is something that you can see your text also and do yourself. 90. This is important. So let's write down question number 90. I've got a question for you also. So here, question number 90 is saying, are crystals of salt like copper sulfate really dry? Are crystals of salts like copper sulfate really dry? That means they look dry. That means when you take in your hand, okay? But are they really dry? We're going to see that. So check with an experiment. So let us do an experiment. Or you can write here, illustrate or prove with an experiment. Illustrate by experiment. So let us do this. Take some copper sulfate crystals. Now copper sulfate is CuSO4. The real formula is this one. Okay, so you take these crystals in a test tube. So these are the crystals, copper sulfate crystals. So this here, copper sulfate. Okay, just write down CuSO4 5H2O. Now they look really dry. Okay, when you look and you find that there's no water. It's quite dry. But is it really dry? We're trying to see. So burn a stove, start heating. When you start heating, after some time, water droplets begin to gather on the upper part of the tube where it's cooler. This part is hot. In the cool area, water droplets collect, right? So and then water droplets collect, and this is blue. Okay, this copper sulfate is blue color, and the blue color changed to white. That is interesting. Then here this white is this one. So after heating, the water droplets are removed from this copper sulfate and it turned white, this one. Then you add some water again, little bit of water. Then it turned again to blue. That proves that copper sulfate is not really dry. There was some water. When you heat, the water droplet appear means there was water hidden inside. When water came out, changed to white color. That proves us that it contains a certain amount of water, right? And this water is responsible for what? Number one, the color, blue color was coming because of the presence of water. And then, because when you heat it, it turned white, no? So the moment water is taken out, the color disappeared. And then this white one becomes powder, okay? No more crystalline. These are now crystals. Blue one have definite shape, sharp shapes that disappear. That means crystalline shape. So this water present in copper sulfate, CH-2O, was responsible for the shape, crystalline structure, and a blue color. So this water that is present in one unit, formula unit of a compound, that is responsible for its color as well as the structure, crystalline shape, that gives the crystalline shape to the compound, is called water of crystallization. So 90 and 91 are discussed here together. Okay. So 91, let me write the question number 91. Question number 91. What is water of crystallization? So the answer for that is here. Water of crystallization is the water molecules present in one formula unit of a substance that is responsible especially for the crystalline shape and also imparting color in some cases. So that is called, exact definition on the text is water of crystallization is the fixed number of water molecules, 2 or 3 or 5 water molecules, here copper sulfate 5 water molecules in one formula unit, not two, one formula unit of a salt. Okay, so let us go and do question number 92, the last second question. So this is video 10. Okay, so video 9 has been done. Once you finish the video 10, you take the TEST-2E. So question number 92, important exercise. You learn something from here. So it writes there, water of crystallization in the following. Find out the water of crystallization in the following. Okay, number one, A. We have used A. So here, copper sulfate. Let us write the formula also. Copper sulfate. Write with your pen, CuSO4 dot 5H2O. And then make a blank with your pen and write this blank with your pencil. B is gypsum. The formula for gypsum. These are common substances, CaSO4, 2H2 with 2 water molecules. What is the number of water crystallization? C is plaster of Paris. These are the common names. Plaster of Paris. Plaster of Paris, or the real name is called calcium sulfate hemihydrate. Okay? This is the real chemical name of plaster of Paris, hemihydrate. The white powder used for when someone breaks his bone and doctor puts it back, join it, there's a white cement kind of cast to straighten the hand. That is the powder plaster of Paris, wet in water, and it becomes like a cement plaster holding the broken bones together for 1 month or something like that to straighten the bone. Okay, so that is plaster of Paris called calcium sulfate hemihydrate. The formula is this one. Ca, from the name itself we can get it. Calcium sulfate means Ca2 plus sulfate, SO4 2 minus. The word hemi means half. No, you know in geography also, northern hemisphere means half of Earth, southern hemisphere. So hemi means half. Hydrate means water. So water means we know. So very easy. Once you know the calcium sulfate hemihydrate, you can make this formula yourself. How much is there? Now in one formula unit, how much water is there? That is called water of crystallization. So here how many unit? 1. See, CuSO4 in the one front. 1 means one formula unit has 5 water molecules, means it has 5 water of crystals. Write with your pencil. Here one formula unit, see, on the front again only 1. So one formula unit of CuSO4 contains 2 water. So gypsum has 2 water of crystallization. And calcium sulfate also, see, one formula unit in the front only 1. Then here half, so the water of crystallization is half. That's how we do. Okay, next 93. So write down question number 93. This is just a general knowledge kind of question, but it helps you. The chemical, okay, the chemical name of plaster of Paris. Just now I told you what it is. Used for casting broken bones as well as for making statues also. Okay, is calcium. Let's just write this one also. Calcium sulfate. So the chemical name is calcium sulfate hemihydrate. This kind of doing yourself helps you a lot, so just do it. Calcium sulfate hemihydrate. Okay, so its chemical formula. So its chemical formula is, and write a blank with your pen and write this one with your pencil. So you can write the formula from the chemical name, not from the common name, cannot give you. Plaster of Paris. Here, calcium, you know your starter, CH-2 plus, sulfate, SO4 2 minus, so 2 cancelled, and dot. Then hemi means half, hydrate means water. Okay, write with your pencil. Okay, so that is the last second question. One more question, that is 94. Okay, so this is 93, and we'll end up with this. Okay, 94. So here, question number 94. Preparation. How is preparation of plaster of Paris? How they manufacture in the industry? The question is saying, how is plaster of Paris manufactured or prepared? So what they do is that they take gypsum. So write their gypsum and know the formula of gypsum. Gypsum is calcium sulfate dihydrate 2H2O, and they will do careful heating. Not exactly at 373 Kelvin. So the temperature should be controlled. If it goes more than this temperature, you will not get the plaster of Paris, it will get spoiled. So controlled heating, you write here, not high heating but controlled heating you do. Then when you do controlled heating, see here, how many water molecule is there? 2. So 1.5 will come out. 1.5 water molecule will go as steam. Steam means aero up gas. Just go out of the test tube or the heating box, plus 1.5. 2 means what? 1.5 plus 1, nah? 1.5 plus 1. You can calculate 1.5 plus 1. 1.5 plus half, sorry. 1.5 plus half. 1 half, half, 1, 1, 1, 2. 1.5 plus half is 2. So 1.5 has gone out, that means only half is left. So you write the remaining formula, CaSO4 dot half H2O. So this is your plaster of Paris, which is also called calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Okay, so that's how plaster of Paris is prepared, by careful heating. Okay, if you heat beyond this, all the water will go out, 2 will go out, and you'll get a dry calcium sulfate, which is no good. It's not plaster of Paris. It cannot cause broken bones. Okay, so you have to be careful that you do controlled heating in this case. Okay, so in this chapter, this is the ending question. Just remember, in this 2E portion, the important compounds we have learned is, number 1, how sodium hydroxide is prepared in the process, chlorine, hydrogen byproducts were formed in the same process, and how they were so useful in industries. And then the second one was baking soda, the one used in baking cakes. The third one was washing soda. Okay, before washing soda, I think the third one was bleaching powder. Okay, bleaching powder used for bleaching clothes. Then we also learned about the washing soda. And then the fifth compound we learned so far is your important one, the plaster of Paris, used for casting broken bones and making statues even. Okay, so you can now go through it carefully and take your test. Okay.